I hate deadlines. Nasty, disturbing things. They get in the way of free flow living. So, of course, I decided to enter Mark Rober's engineering competition, and I will have only 1 month to prototype and submit a video of the working machine. Technically, they gave us 2 months, but I wasn't able to start until halfway through, so that's great. The guidelines they gave us for the machine are roughly as follows. Find a problem around your house that a machine could solve. Making breakfast, turning off the lights, firing heat-seeking missiles at bedroom invaders, and build a machine to solve that problem. It doesn't have to be perfect, but it should work. Easy, right? Well, maybe. Unless you decide to build a machine that can automatically make a cup of hot chocolate. It might be easy if you didn't choose to create a machine with complex mechanisms. Oh my god.
Things are totally not going as planned.
Oh, grind. Oh, I hate it. Lines and lines of code in a language I do not understand, and numerous janky solutions to mind-bending problems. Sound like a recipe for disaster? Awesome. Then let's dive into the project, starting at day 1. First, we designed the machine in Blender for 2 reasons. A, as a blueprint to me, and B, so you can see what will hopefully be the end result.
2 hours later.
And hey presto, if we take a quick look at the design, we can see that we have a mini electric kettle which will boil the liquid of your choice, and we have a food grade heat resistant pump to draw the liquid out of the kettle down this tube and into the mug. We also have a hopper up here to dispense the mix down into the cup once this little trap door is opened by this motor. To keep from scalding the milk, if that's the liquid you're using, I've built in a temperature sensor to trigger this motor to flip the kettle off once the temperature of the milk gets too high. The whole thing will be powered by Arduino Uno R4, and the frame will probably be built of Legos.
You serious?
The first thing to build was the whisk mechanism. Deciding to use a combination of normal Legos and LEGO Mindstorm's EV3 parts, I got to work. Oh, and duct tape. I used duct tape, of course. The next thing on my list to build was the hopper, which I made out of totally food-safe acrylic. Unfortunately, I discovered that the plastic wrap makes really good ASMR, and I spent far too long doing that instead. Anyway, I began rolling up the acrylic sheets to make the hopper, but then it snapped, and I realized acrylic might not be the best material. So instead, I repurposed this B12 supplement bottle by ripping the sticker off and making as many holes as I could. Finding this looked far too much like recycled parts, I covered it in black duct tape, and now it looks like a duct tape covered, wholly recycled part. Very professional. I'd fix it, but I had no time, so I continued. Here, I'm beginning to assemble it. You might be wondering why I'm choosing cardboard as the frame.
How stupid.
You're thinking.
Cardboard is weak, and hot chocolate, if spilled, will make it disintegrate. What sort of engineer does this guy think he is anyway?
Thing is, as I began putting the pieces together, I realized it might be best if I made a prototype of this machine first, just to make sure all the components worked. I'm somewhat confident in my ability to assemble a working machine, but I have much less confidence in my ability to code.
Foreshadowing?
And so I thought it best to get to the coding stage as quickly as possible. I also think it's best if we get to the next stage of the video as quickly as possible, so let's zip through the rest of the assembly with a quick build montage.
Hey, light go blinky. I am now officially an Arduino master.
Right, so I've written up a program to individually test all of these pieces, so let me give you the rundown before I show you. First of all, we have this totally overkill 25-gram servo motor to turn this on and off switch on the kettle. Next, we have a miniature servo motor to open the gate on the powder hopper. When it turns, this little acrylic piece will open up the hole, and it should allow the mix to fall down into the cup. We've got a high torque 9-volt motor here, which turns this gear, which allows the geared rack to move up and down. We have a second one of these motors to spin the whisk here, and that motor is triggered by this momentary push switch. So when I press the button, it turns the whisk, which I can quickly show you now as it's not a coded mechanism. Okay, it got a bit stuck, but it does work. And the push switch is triggered when the geared rack comes all the way down and presses the switch. Next we have the kettle, of course, which can heat water to boiling point in 4 minutes, so your hot beverage should be ready very soon. But, however, I don't want the water to reach boiling point, or the liquid I should say, as that would scorch milk if you're using it, and it would also scorch my pump, which can't stand being submerged up to temperatures of 100 C. That's why I've included this temperature sensor to trigger the off switch on the kettle when the liquid reaches about 60 C, and that just goes in there. And last of all, we have this 6-volt battery pack, which powers all of the high power components, the servo motor, and the DC motors. So let's give this a quick run. I'll just put my camera on the tripod. Alright, so now let's run the test program, and we're gonna start with this servo motor. Now, this will be attached to something once I finish the frame, but right now it's loose, so I'll just hold it while I run the program, and it should turn the switch. Alright, here we go. And it turns the switch, and I can just run it in the other direction, and it turns it again. On to the next component. Alright, now, so when I press the correct keyboard key, it ought to turn this little plastic shield here. Hey! Look at that. And now for the next motor. So, let's test it out. Why didn't it work? Why didn't it work? What the hell? Run the whisk loop. What? Why is it not doing anything? Come on, we rehearsed this. What? The motor's not broken? Guess the code isn't running. Something like that. What? Things are totally not going as planned. Oh, good lord. Cut! Okay, I did some very calm and collected debugging of my code and discovered that it wasn't running the function in the proper place, which is why it just wasn't running at all. Anyway, let's give it a go. Yes! Spinning! It's spin it! Ha 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 ha! And up we go. Yes! Having now confirmed everything works, I disassembled the prototype and began work on the actual machine. I chose this large wooden circle as the base of the frame, but I ended up changing that later. The first thing I did to improve this version was change out the whisk motor. I wanted something that could spin faster and mix the hot chocolate more effectively. I also wanted to see if I could attach the whisk more securely to the motor than before, which is why I'm soldering it here. This, of course, didn't work, and finally I ended up jamming the motor and whisk into a piece of hot glue stick. When powered, this thing spins terrifyingly fast. So fast that it deforms the whisk. This is something that will cause me some trouble later, but I don't know it yet, so let's leave me in blissful ignorance. The last of the parts I had ordered arrived today, so I got to work on the sound system. I'm using a mini DF player to play sounds from a micro SD card, and I'm attaching it to this 3-watt speaker I had lying around. After wiring it to the Arduino, I inserted the SD card and waited for the audio files to play.
One eternity later.
Oh my god. I just spent all day troubleshooting this thing. All day. I think I've been at this for like, I don't even know how long. I've been at this for maybe 4 hours. And it wasn't working and it wasn't working. And I discovered the solution. I just discovered that I didn't have ground. I didn't have ground plugged into the breadboard. Which is why the whole thing wasn't running, wasn't powering, wasn't doing anything. That's annoying. What a waste of time. Okay. On to the next part of the project. Bloody. After that soul-crushing realization, I began constructing the hopper. I'm making the main body out of a thick cardboard tube, and making the funnel out of card paper. The last iteration of the hopper didn't allow the chocolate pixie dust to fall out properly, so I'm making the opening much larger here. I'm also changing the mechanism. Instead of having a gate open to allow the hot chocolate mix to fall out, I'm having a flap rotate inside the hopper to agitate the pixie dust and force it to fall out, and this flap will be controlled by an extra servo motor I found lying around. Another major change I made to this design was adding a conveyor belt. When assembling Mark 1, I wasn't able to place the hopper directly above the cup, which meant that hot chocolate mix would always spill over the edge. So what I'm doing instead is moving the cup on a conveyor belt to place it beneath each station. Position 1 puts it under the water and pixie dust dispenser, and position 2 will place it under the whisk, ready for mixing. I began experimenting with a few different mechanisms to move the cup around, but this one didn't work. And I ended up settling on a proper conveyor belt. There's turning out to be a lot more Lego in this design than I would like. Here, I wanted to see if I could wire the motor to spin in alternate directions, depending on which momentary switch was pressed. This is because I didn't have enough motor ports on my motor driver chip, and I was thinking I could use a servo connected directly to the Arduino to trigger the switches. I didn't realize until the battery started smoking that what I had actually created was an over-engineered short circuit. After nearly becoming a modern-day Guy Fawkes and blowing up my studio, I started tweaking the whisk mechanism. Compared to the rest of the machine, it's so ridiculously tall, and I was sure I could make it at least a little shorter. Thankfully, I could, and so I moved on to the frame, which this time around I'm constructing from wooden planks. It looks a wee bit janky, but it's still better than cardboard, and at this point I had no time left to care about how things looked. I had only 7 days left to assemble it, edit the code from Mark 1 to fit Mark 2, and iron out all the bugs, mechanical and otherwise. It sounds like a lot of time, but honestly, with this sort of thing, it isn't. Okay, so I finished the wiring here. It's a bit of a mess, but not really much I can do about that right now. I don't want to solder any of these connections, which is why I'm using the breadboard. This is what the machine looks like so far. So, let's hope I don't mess anything up.
12 seconds later.
Okay, we've encountered our first problem. The motor that we're currently looking at isn't pulling the rack up. The gears aren't meshing properly. But thank goodness it's a mechanical problem. That's something I can fix. Like the conveyor belt down here, that wasn't spinning properly either. But again, that was an easy fix. I just tightened the duct tape, made the duct tape belt shorter, so that was easy. Let's hope we don't run into any more problems. Okay, I've just finished coding the whisk rack motor. So now I can make it go down and up, which is great. That took a while because I've added a new feature in Mark 2. So you can see here, there's this little switch right under there. And when the motor lowers, this little section with the red Legos on it presses the switch and it tells the motor up here, the yellow one, to stop turning. Then it waits for 5 seconds. I've chosen 5 because I'm too impatient to wait for the full whisk time, and goes back up. Slipping up my chair. And when this little momentary switch detects that it's been pressed, it stops the motor again. So it's much more precise than the code I had last time. Anyway, let's see it run. Oh. That's so dumb. Why did it do that? Oh, this mechanism is rubbish. Anyway, the code is working. As you can see, the motor does not want to work properly, but it's going back up now anyway. Oh, grind. Oh, I hate this. Oh, God. Okay, that was awful. Okay, 2 days left. I've just been debugging the motor code, the code that makes the whisk rack go up and down. That took a weirdly long time, but I guess it's because I was also fixing the mechanism up here. Focus, you idiot. But I guess that's because I was fixing the whisk mechanism up here. For some reason, the gears just weren't meshing. Anyway, it works now. As you can see, I haven't actually wired the big motor, the big silver one here, the one that actually spins the whisk, because I've used up all my motor ports. And so in the previous design, this switch we're looking at right now triggered the whisk motor to spin. But now what the switch does is it tells the motor, this one up here, to stop moving the whisk rack all the way down. And of course, I can't use the same switch for 2 things, because then things explode, as we saw earlier. So it took me a weirdly long time to figure out a solution for it, but then I just realized I can just put a second switch under there. So that's what I'm gonna do, and hope that it doesn't take a really long time, because I have very, very little time left. I'm just not panicking. It's not panicking. It's not panicking at all. So I've just wired the whisk here, and I've come across a small problem. We actually saw it earlier while I was setting up the motor. This thing spins terrifyingly fast, so fast that it deforms the whisk. That, my friends, is a problem. So I'm gonna see if I can learn some new just electrical engineering magic and use resistors to slow this down. Hopefully that should do it, because I don't have any speed controls left. I have one of these, but I blew it in a different build, so let's fix it, see if it works. Editing me here. No, I was not dumb enough to do that. I did some research after recording that clip there and discovered that actually using resistors to lower the voltage of a power source is an extremely bad idea. So I did something else that was not quite as dumb, but still not great. I used a bunch of diodes connected in series to lower the voltage from the 6-volt power source, and yes, they get really hot when I power the motor, but they work for a few seconds without becoming terribly hot, which is all I'm asking from them. After all, I really did not have much time left to figure this out, so I just went with what worked. Anyway, back to the video. I think I'm just panicking just a little bit. Just want to put my head through the wall just a tiny bit. The whisk mechanism has stopped working properly. Really great time. It doesn't seem to want to register the signal from the down button here to tell it to stop moving down, and as such keeps grinding the gears and has made the gear here snap off. No, I should say snap, just the glue has just come undone. It's all just grinding, it's terrible. I don't know how I'm gonna get this done in time. Darkest hour reached. Okay, I think I've fixed it. Excuse the scrolling bars in the video. My lighting's never done that anyway. I don't know if it works all the time. It seems to be registering the push button switch to tell it to stop going down, and that's really what I want. I'll show you. So when I run the program, the whisk mechanism goes all the way down, whisks for a while, and then comes back up and stops when the up switch has been pressed. But of course, when I restart the program, the up switch is already pressed. So I'm gonna have to fix that. But that does mean that I have to manually push this down just a little bit. There we go. And up it goes. And, well, it works, sort of. So, did I succeed? Did I submit a video of my project working in time? Well, judging from all that you've seen in the video, take a guess. I did! In the end, it actually worked. Never mind the fact that I submitted it at roughly half an hour before the deadline. That's completely irrelevant. Anyway, here it is. Power on. Your hot chocolate will be ready in 4 minutes. And the kettle's on now. Here we go. The water's now heating. You can see it's dispensed the powder. Here we go. It's beginning to boil. Listen to that. Any second now. Aha! And it's going into the cup. Now the conveyor belt will move the cup along. It's going. And it's mixing it. It's mixing it. It's mixing it. Yes! Ignore the wire. Definitely supposed to be there. Whoa! Oh, I'm genuinely so glad that worked. It was genuinely such a relief to get that in, to finally be finished with the project. I definitely enjoyed it, but like I said at the beginning of the video, me and deadlines, we don't mix. But in the end, I did it. As for whether I'll actually win, well, I think the chances are quite literally 1 in a million, but a guy can hope. Anyway, until I get confirmation of whether or not I've won, I'm going to wind down with yet another complicated project, because I'm dumb that way. This one's pretty stupid though. Watch out for it in the next video, and until then, see ya!